Hello everyone. So in this video, we'll find the key features of a polynomial function from the given graph. So the first thing we have to find is the number of turning points. So turning points are points where the graph changes direction. So we start by analyzing this given graph from the extreme left side. So the graph is going up as we go from left to right, and then it reaches this point and then it turns back down. So this point here is the first turning point from the left side. Now then the graph starts going back down, and then when it reaches -4, x equals -4, it turns back up. So that's our second turning point. And then it starts going up and then it turns back down again. So this is our third turning point. And then it starts going down and then again turns back up at this point. So this is our fourth turning point. And then it starts going up and it reaches the top and turns back. So this is our fifth turning point. So in total, this graph has 5 turning points. So now we can move on to the next part, the end behavior. The end behavior describes where the graph is heading on the extreme ends or around the vertical asymptotes or horizontal asymptotes. Now this is a polynomial function, so there are no asymptotes in this case. So we just have to describe the end behavior on the extreme left and extreme right of this polynomial function. On the extreme left, as we go on the left side, the graph keeps going down. So our end behavior on the extreme left will be as x approaches -infinity. That means as we keep going to the left side of this graph, the graph keeps going down. So we write y approaches -infinity because the graph is headed in the downward direction. Now we can write the end behavior on the extreme right. So as we keep going to the right side of the graph keeps going down. So we write as x approaches positive infinity, y approaches again -infinity because the graph is heading down on the extreme right. So this is how we identify the end behavior for a polynomial function. So we just write the end behavior on the extreme left and on the extreme right of the x-axis. Now is this an even or odd degree? Now in this case, the graph is originating in quadrant 3. So as we go from left to right, the graph comes from quadrant 3 and then makes some turning points and then it goes into quadrant 4. So that means this is an even degree polynomial function. So both the starting and the ending is on the lower side of the x-axis. So this is an even degree function. The other way to identify the degree is by analyzing the end behavior. So since the y approaches -infinity for both ends, so that's why the degree is even. The leading coefficient in this case is negative because the graph is starting from the lower quadrant 3, and is ending in quadrant 4. You can also think of this as a graph that is opening downward. Just like for a parabola, we say the parabola is opening down or opening up. So this graph is equivalent to a parabola opening down. So that's why the leading coefficient is negative. Now we have to write the x-intercepts and their multiplicities. So we can start from the extreme left. So the first x-intercept is -7. So we can write it as an ordered pair, -7, 0. Its multiplicity is 1 because at that x-intercept, the graph passes straight through the x-intercept. So the multiplicity value for this x-intercept is 1. Now the second x-intercept is -4. So we write it as -4, 0. And for that, the multiplicity is 2 because at that x-intercept, the graph bounces back. So the graph is coming down to get to the second x-intercept at -4, but it is pushed back. So the multiplicity at that x-intercept is 2. Now the next x-intercept is 1. So we write it as 1, 0. And at 1, the graph passes straight through it. So the multiplicity at that x-intercept is 1. Now the next x-intercept is 4 and the graph passes straight through it. So the multiplicity at x-intercept 4 is also equal to 1. Now the next x-intercept is 7 and the graph passes straight through it. So the multiplicity at 7, 0 is also equal to 1. So in total, there are 5 x-intercepts. So these are the x-intercepts for this graph and their respective multiplicities. Now the last part is the degree of the polynomial. So the degree of the polynomial will just be the sum of the multiplicities of all the x-intercepts we found. So we just have to do 1 plus 2 plus 1 plus 1 plus 1. So I get 6. So this is a 6th degree polynomial. So these are the steps you have to keep in mind to answer this type of question for a polynomial function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.